So we're going to go through our completing the square mini review. The first problem, we are supposed to complete the square, graph the parabola, and then describe the transformations from the parent graph. So the first part of completing the square is always setting up our work. So we give ourselves blanks on each side, and we move over that existing value because we're going to fill in our own. Now the next thing we want to do is calculate our b value and b over 2. So in this case, our b value is 22. If I divide that by 2, I get 11. So if I can take b over 2 and square it, that'd be 11 squared, which is 121. That's the number that is going to complete my square. If I added 121 on the left side, I need to add 121, to the left side as well, because I added it to the right side. So then from there, we can continue to rewrite. So the left side I'm not going to change. But the whole reason of adding 121 was so this trinomial is now a perfect square trinomial. I know exactly how it factors. The numbers that multiply to 121 and add to 22 are positive 11 and positive 11. So I can write that as x plus 11 squared. Our last step is just getting y alone. So I'm going to subtract 121 from both sides. So I get y is equal to x plus 11 squared minus 125. So that's step number 1. We've completed the square to get vertex form. Now we also need to make a graph and describe the transformation, so we'll do both at the same time. So to describe the transformation first, just so we can better see that, I'm going to do that in a green marker. And the transformations are going to come from our vertex form. So if I see a plus 11 inside parentheses, this is actually going to move it left 11 units. And then the minus 125 at the end moves it down 125 units. So when I graph the function, the first thing that I can do is I can plot my vertex, which will be at negative 11, negative 125. And I'm not super concerned about the scale as long as you put it in the right quadrant. The next thing I'm going to graph is the y-intercept. And remember, the y-intercept is that c value in standard form. It's that number that we've moved over and dealt with at the end. So our y-intercept is 0, negative 4. And then if I know where the y-intercept is and I know where the vertex is, I can always find its partner to the y-intercept. So like this one here is 11 units away from the axis of symmetry. So if I go 11 units on the other side of that, that would bring me to the point negative 22, negative 4. And those are the 3 points that I need to graph my parabola, and I am done. So moving on to example number 2, we have to do the same exact thing. So we start completing the square in the same manner. We set up the problem appropriately by giving ourselves a space on the left, giving ourselves a space on the right, and then moving over that existing c value. Now what we notice with this one right away is the leading coefficient is no longer a 1. So our first step, we must factor the left side by factoring out whatever that a value is. So I have to pull out a negative 3, which means I need to divide this term by negative 3 and that term by negative 3. So in parentheses, I'd be left with x squared plus 4x. Then there's a blank, and then we still have that plus 9 at the end. So similar to before, now we are just focusing on what's inside the parentheses. So I can figure out my b value and my b over 2. So if b was equal to 4, b over 2 is equal to 2. So my b over 2 squared would be equal to 4. So 4 is a number that goes there. Now, most importantly, as we're learning, I added negative 3 groups of 4 to the right side. So 4 times negative 3 really means I added negative 12 to the right side. So I need to add negative 12 to the left side. So now, just like before, we are going to rewrite. So this is y minus 12. We have a negative 3. And the whole reason that I chose to use the number 4 was so I could factor this into a perfect square trinomial. And I can double check that the numbers that multiply to 4 and add to 4 would be positive 2 and positive 2. Our last step is just getting y alone by adding 12 to both sides. So our vertex form, y equals negative 3, x plus 2 squared plus 21. So to describe our transformations, this negative is going to vertically flip our graph. You guys can also call it a reflection. The 3 itself is going to be a vertical stretch. Doesn't matter what direction the parabola is facing, up or down. That's what the negative does. The 3 is going to stretch it. I see a +2 inside parentheses. That moves our graph left 2 units. And then the +21 at the end moves it up 21 units. So we can make our graph. So our vertex has been moved left 2 and up 21. So I'm going to put that right here. I'm going to call that point 2, 21. And again, I'm not worried about the scale as long as it's in the right quadrant. Excuse me, that's a -2, 21. Now the next thing, we would want to plot the y-intercept, and we know the y-intercept is the original c value in standard form. It's that number we've been moving over. So our y-intercept is 9. And if we know where the vertex is, that's the middle of our parabola, we can always find a partner point. So the y-intercept is 2 units away on the right side of the axis of symmetry. So its partner is going to be 2 units on the left side, which would be the point -4, 9. And after I draw my graph, it does look like I described it down here. And that is our final answer.